Hey guys, we're working on our volume word problems. I know these are going to be tough, but the only questions I'd like you to do are 1 through 4, so the whole front page. And then on the back, we're going to go just 8, 10, and 11 with a little bit of review. Okay, so we're going to do a few of these together in this video, and I really want you to challenge yourself and try the ones that we did not get to try. So we'll start with question 2. Find the volume and surface area. We're actually just going to focus on volume today. Of a prism with a height of 4 inches and a 3 by 3 inch square base. Compare the results with the volume of a cylinder with a height of 5.1 inches and a diameter of 3 inches. Use the results to explain why canned goods are usually packed in cylindrical containers. Well, the main idea is that we're probably going to figure out which one holds more material, because if one holds more, that means they can get more product in there, which would be great for people when they're buying a product. It holds more. So let's start with the prism here. Well, our volume for a prism is length times width times height. Now it says that the base is 3 by 3, so we don't really know which one's the length and the width, but it actually doesn't really matter. So let's do 3 times 3, and then it says the height is 4 inches. So if you multiply all those together, we get about 36. Remember, if they're all inches, then the units are going to be inches cubed. So this one holds about 36 inches cubed in terms of the prism. Then we'll look at the cylinder. Well, the first thing I want to show you is if I draw this cylinder, okay, the quick thing that we need to keep in mind is that the diameter is 3. Okay, so this whole length right here is 3 inches. So that means that the radius is 1.5 inches. We only want the radius in our formula. So the volume of a cylinder is pi radius squared times the height. Well, we're given all that information. Pi, we already found the radius was 1.5, and then the height was 5.1 inches. So if you multiply that, we approximately get 36.05 inches cubed. Okay, so we have 36 inches cubed and we have 36.05 inches cubed. Now obviously we'd have a little better idea if we were to look at the surface area. Maybe that the cylinder covers less surface area, so it's less product to actually make the container, and you actually get to fit more in there in the cylinder. But just with the volume, you can see that it gives you 5/100ths more actual material, or sorry, not more material, actual product that goes in the cylindrical containers. Okay, question 3. The Caribbean coral reef tank at the New England Aquarium is a cylindrical tank that is 23 feet deep. Okay, so this whole height right here is 23 feet and 40 feet in diameter. So that's good to know because now we only have a 20-foot radius. Okay, now it says how many gallons of water are needed to fill the tank. Well, we don't really know gallons because we're given everything in feet. So let's at least find the volume in feet. Well, it's a cylinder, so pi r squared times the height. Okay, so pi radius we found was 20 times the height, which is 23 feet. If you multiply all that together, you get about 1806.42 feet cubed. Well, that's good to know because now we have at least the volume of the whole cylindrical tank. And then it says how many gallons? Well, it says that 1 gallon of water is about 0.1337 cubic feet. So let's set this up. We know that the tank fills 1,806.42 feet cubed. We can multiply that by the unit conversion. Well, if I want my feet cubed to cancel out, I need to put my feet cubed in the denominator, because now the feet cubed and feet cubed will cancel out. But remember, for a unit conversion to work, I need to have equivalent things in the same fraction. So that means I need to have 1 gallon per 0.1337 feet cubed. Now my feet cubes cancel out. I multiply across and divide by 0.1337, and I get approximately 13,510 gallons, 0.99 gallons. Okay, good to know. And then it says determine the weight. Well, that's weird. But now it says that 1 gallon weighs about 8.56 pounds, and we're going to be filling it with salt water, so that's good to know. If we have the gallons, we can now find the pounds. So let's write out what we have in gallons. 13,000, 10.99 gallons, and let's multiply by the unit conversion we have. If we want gallons to cancel out, we need to put gallons in the denominator. Okay, so the gallons cancel out, and we're left with pounds. Multiply across, LBS stands for pounds, multiply across, and we get 115,654.07 pounds. Okay, so just a little bit of unit conversion here. We started with feet cubed, we converted to gallons, and we converted to pounds. Okay, the last question I'd like to do is 4b, which says find the solid. So what we have here is we have a really big cylinder, and then we have an inside cylinder pulled out from within it. So we're just left with the outside part of that cylinder. Okay, so what we need to do is we need to find the volume of the big one. So V of the big, we need to subtract the volume of the small. Because if we take the whole volume of the big one and pull out just the volume of the small one, we're left with all that's remaining. So let's figure this out. Pi r squared, well, what is my radius of my big shape? Well, if the radius of the small shape is 3, and just this little piece right here is 8, to add those together, we get a radius of 11 inches. So 11 squared times the height, which is 11 as well, minus pi, the radius squared. Well, the radius of the small cylinder is 3, and then the same height, because both heights have the same cylinder. Or sorry, both cylinders have the same height. So now we multiply that together, we get 4,181.46, and we're going to subtract 311.02. So 4,181.46 is the big volume of the big cylinder, and we're subtracting that small cylinder, and we get whatever is left with this 3,870.44 inches cubed. Question 4a is a very similar idea, but instead of using cylinders, we're now using prisms. Okay, the last thing I want to talk about is on the back, page 2. You should see that questions 8, you're simplifying radicals. Question 10, you're using trig. You can use our 30, 60, 90 special right triangles or trigonometry. And question 11, just solving a quadratic equation. Isolate what's being squared, square root both sides, and you'll get your 2 answers. Okay, take a look at all this work, but I promise you it's a little bit of a challenge, but I promise you guys can do it. Good luck.